So today we're going to talk about the mole. And remember from earlier, we said the mole is the SI unit for amount of substance. So just like if I have a dozen donuts, we know exactly how many donuts I have. I have 12, right? So if I have a mole, I have this number called Avogadro's number. It's a very, very large number. But it's 6.02 times 10 to the 23rd is my number of moles. And that's why we celebrate Mole Day on October 23rd. Because it's 10 to the 23rd power. So at the end of the month, we'll have a little Mole Day celebration. So why do we care about this number? Why is this number important? Well, if I look at the periodic table, I see that carbon-12 weighs 12 AMU, atomic mass units. So the mole is if I had exactly enough particles to get that into grams. So if I had 6.02 times 10 to the 23rd carbon atoms, I know immediately that I have 12 grams of carbon atoms. And that's a lot of atoms, but it's not a lot in terms of grams. 12 grams isn't that much. Just to give you an idea of how large the mole is, it's 6 with 23 zeros. If I had the United States and I had a mole of popcorn, so each atom was the size of a popcorn piece, I would be able to fill the United States up to 500 kilometers. So past the International Space Station, past Mount Everest, way out there in space, that's how much popcorn would be a mole. It's a lot. So one concept we need to understand when we're dealing with moles is the molar mass. And this is going to tell me how many grams there are in 1 mole of the substance. So if I have a mole of carbon, 12 grams would be the molar mass, but I write it in units of grams per mole. So it's always equal to the atomic mass in atomic mass units. So here's some examples of some chemicals I have a mole of. And I know the size is a little bit difficult to see there, but maybe the copper wire gives you a little bit of scale. That's how much copper wire would be a mole. We've got a mole of zinc, a mole of copper, magnesium, sulfur, silicon, lead, and tin. Each of those represents a mole of the substance, and you can see they give me the molar mass of each one. And again, we already made that analogy, but just like a dozen is 12 items, a mole is 6 trillion items. Maybe trillion, depending on, I don't know how many zeros, what I would name 23 zeros. So, gram to mole conversions. First, we're going to be able to convert how many grams of helium there are based on how many moles I have. So if I know that there's 4 grams in a mole of helium, how many grams do you think there would be in 2 moles of helium? Yeah, it'd be 8. And we can figure that out simply, but it's not always going to be easy numbers like that. So just to show you what we're doing here, 2 moles is what I'm trying to figure out, 2 moles of helium, and I want to figure out how many grams there are. So I want to convert moles into grams. I know that there's 4 grams in 1 mole. Just take 2 times 4, it gives me 8. I guess there weren't really any sig figs, so 8 grams of helium. So Avogadro's numbers can be used to find the number of atoms in an element based on the number of moles. And in these calculations, we say units of atoms per mole. But Avogadro's number can represent all sorts of things. It can represent atoms, it can represent molecules, it can represent electrons. It's just any item. So it could be donuts. You could have how many donuts are in a mole. There'd be 6.02 times 10 to the 23rd donuts in 1 mole. So here's a little handy chart I drew on the board. It's got mass, atoms, and moles. And it tells me if I want to go from grams to moles, all I have to do is divide by the molar mass, which is found on the periodic table. And if I want to go from moles to grams, I'm going to multiply by that number that's on the periodic table. If I want to go from particles to moles, I'm going to divide by Avogadro's number. And if I want to go from moles to particles, do the opposite. I'm going to multiply by Avogadro's number. Now notice, they link the bottom two with arrows, but really there's no direct path between mass and atoms. We have to go through the mole. So to get from mass to number of atoms, I have to divide by molar mass and multiply by Avogadro's number. To get from atoms to mass, I have to divide by Avogadro's number and then multiply by the molar mass. So I always have to go through moles to get from one side of the triangle to the other. So the best way to do this, I think, is to go through some example problems. So we have in the first one, what's the mass of 3.50 moles of copper? So I know I've got 3.50 moles of copper. So based on my triangle there, I'm in moles and I want to try to get to grams. So I'm going to multiply by the molar mass. So I need to multiply by how many grams of copper there are in a mole of copper. My periodic table can tell me that. If I look at copper, I see that it has an atomic mass of 63.5, so let's use that. (63.5), and since I have 3 sig figs, I take 3.50 times 63.5, and I believe that gives me 222 grams because the moles cancel out. So 222 grams is my final answer. And you can write copper there. When we have different elements in the future, it might be helpful to keep that straight. Any questions on what I did there? It should make sense because, I know that 1 mole of copper weighs 63. So if I have 3.5, I should have, 3.5 times that, which is a lot more grams. We can go backwards. We can take 11.9 grams of aluminum, convert that into moles of aluminum. I know that there's 1 mole, and my periodic table says that aluminum weighs 26.9 or about 27 grams per mole. So that number came straight off the periodic table. Remember, I divide based on my triangle. I divide whenever I'm going from the amount of grams to the amount of moles. And when all is said and done, 11.9 divided by 27 should give me 0.441. In your calculator. Any questions on that? Now here we've got particles. They're asking me how many moles of silver are in this number of particles. So we're given a particle and they want moles. So it looks like I'm going to divide by Avogadro's number. Remember, there's usually a lot of particles. We know there's a lot of particles in a mole. So if I have a big number, I'm probably dividing in this case. So 3.01 times 10 to the 23rd atoms divided by 6.02 times 10 to the 23rd atoms in 1 mole. Atoms go away. And they gave us this conveniently half of 6.02. We know that that's going to be 0.5. I should convert that into the correct sig figs because there are 3. It's going to be 0.500 moles, a half a mole. But just to I do want to show you how to do that because I want us to get used to using the calculator in this way. There goes my PowerPoint. But it's 3.01 E23. Don't put any 10s in there. Just leave it 3.01 E23 divided by 6.02 E23. And I get 0.5. So just to remind you how to do that. Doing too much for my computer to handle, apparently. So we do have one more problem I want to go over together and then have you try some on your own. The mass in grams of 1.20 times 10 to the 8th atoms of copper. This is one where we don't have a direct link. We have to go from atoms, number of atoms, to mass in grams. See how the arrow, it tells us we have to divide by the Avogadro's number first, just like we would have to get to moles here. And then to go from moles to mass, we're going to have to multiply by the molar mass. We're going to divide by Avogadro's number and multiply by the molar mass, as you can see here. So 1.20 times 10 to the 8th. I should write atoms. We're going to divide by Avogadro's number, 6.02 times 10 to the 23rd atoms in a mole. And we're going to multiply by grams per mole of copper. We already said it's 63.5. That's from the periodic table. And we have a two-step process. So divide by 6.02 times 10 to the 23rd, multiply by 63.5. So 1.2, and it's already written up there, but just so you can see me type it in, 1.2 times 10 to the 8th divided by 6.02 times 10 to the 23rd times 63.5 gives me 1.26. Don't forget about that tag at the end. There's that times 10 to the negative 14th at the end there. I already forgot my number. It was what? 1.27. So 1.27 times 10 to the negative 14th grams. So with the two-step problem, does that make sense? How we go through both steps to get to the other side. You always have to go through moles to bridge from grams to particles, or particles to grams. So I have a couple questions here. First off, what's the mass of 1.50 moles of sodium? And I also have how many moles of carbon are in 28 grams of carbon. And that's it for chapter 3.